Assalamualaikum and hi everyone. So this is chapter 4, Numerical Differentiation. So you have learned in Engineering Mathematics 1 on how you want to differentiate a function. But in this chapter, we are going to find the numerical value. Okay, the numerical value of a derivative of a given function. Okay, so this is the subtopic that we need to cover, and this is a bit of introduction for this topic. I think you can read on your own. And basically there are three types of different formula. So we have forward, backward, and also centered different. And in this chapter we are going to approximate the first derivative or maybe the second derivative until fourth derivative by using the formula given. Okay, so it depends on the question, and also it depends on the situation on which formula that you are going to use. Okay, alright, so numerical differentiation. So this is all the list of formula in this chapter. So all this formula will be given in the list of formula. So you just use the formula. So depends on the question. You read the question. If let's say the question asks you to use the 3-point forward, so you use the 3-point forward, and it depends also on the derivative. For example, this one first derivative, third point forward, third point backward. So depends on the question, and also sometimes it depends on the situation on which formula that you are going to use. Okay, right. Okay, let's do one example. So example 1 is from the sample test 2 2020-2021. So we have this data. So we have x, f, 3 plus x, and so on. So first question, estimate first derivative of 3.0 by using the 3-point centered different formula. Okay, so refer to the list of formula. So 3-point different formula. So this one. So this is the formula. So we are going to use this formula. Okay. Okay. Question number 1, f prime 3.0. Okay. So f prime 3.0 is equal to f prime 3 plus 0. So equal to 1 over. So we are going to use this formula, but first of all we have to know what is the value of h. Okay, so h is the step size. Okay, back to the data. Okay, how we want to find h? Okay, we have to refer to this one. From here to here, 0.4 to 0.2 is 0.2, and similar to this one also 0.2, 0.2, 0.2, and also 0.2. Therefore, for this case, h is equal 0.2. Okay, so 12h is 0.2, and then negative f, x is 3 plus 2, 0.2 plus 8 f plus 0.2 minus 8 f minus 0.2 plus f minus 2, 0.2. Okay, so we have over 12 times 0.2, so we get 2.4, negative f 3.4 plus 8f 3.2 minus f 2.8 plus f 2.6. Okay, and then how you want to find the value for this function? So this one 0.4, 0.2, this one negative, because our first x is 3, so here negative 0.2, and this one negative 0.4. Okay, so back to the formula. So first 0.4, so 0.4 here. Okay, so put to 1 over 2.4 negative 2.0416 plus 8, so this one 0.2, so 0.2, this value 2.0113 minus 8, so this one negative 0.2, so negative 0.2, this value 1.4471, and then plus negative 0.4 is 1.8762. Okay, and then by using your calculator so your answer will be 1.8118. Okay, it's very simple. So this is the answer. Okay, and then for number 2, estimate first derivative of 3.1 by using the most appropriate finite difference formula. Okay, so this is first derivative, and then we refer to the formula for the first derivative. So we have number 6, first derivative, and also first derivative. Okay, now we have to choose which one is the most appropriate that we can use, we can apply if we want to find the first derivative for 3.1. Okay, now so 3.1, we have h is equal to 0.1. Okay. Okay, now f prime 3.1 plus 0. Okay, and then if we want to find the most appropriate finite difference formula, okay, we refer to the list of formula. If let's say we want to apply the 3-point centered finite difference, so we substitute here. So 3.1 plus 0.1, we have 3.2 minus f. So 3.1 minus 0.1 is 3.0. So these two functions, so we can obtain from the table. So this one we can use. Okay, now let's check for the forward, backward, and also backward. Okay, if let's say we want to choose forward, okay, so f x is 3.1 plus 0.2, so we have 3.3 plus 4f 3.2 minus f 3.1. Okay, here we need 0.3, 0.2, and also 0.1. Okay, now we back to the data. So we don't have the data at x 0.1 and also 0.3. Therefore, we cannot use the 3 point forward. Okay, now we check for the backward. Okay, for the backward, here, so 3f 3.1 minus 4f 3.1 minus 0.1 is 3, and then plus f 3.1 minus 0.2, 2.9. Okay, so here, so we need data at 0.2 negative 0.1 and also negative 0.2. Okay, the problem here, if we want to apply the 3 point backward, okay, we don't have the data at 0.1 and also negative 0.1. Okay, we don't have the data at x negative 0.1 and also 0.1. Therefore, the most appropriate formula that you can use is number 6, 3 point centered different formula. Okay. Okay, now okay. So number 2, f prime 3.1 by using the centered different 3 point centered equal to 1/2 h f, so 3.1 plus 0.1 minus f 3.1 minus 0.1, 0.2 2 minus 3.0. Okay, so we need data at 0.2 and also 0. So 0.2 is 2.0113 and 0 is 1.3478. 0.2 2.01 minus 78. So by using your calculator, so you will get this answer. Okay. Alright, okay, so this is example 1. Okay, let's start example 2. So example 2 is from sample test 20.2021 2022. So we have x and also fx, and then number 1, state the number of possible solution could be obtained to approximate the first derivative of 2.0 by using the 3 point backward formula. Okay, by using the 3 point backward formula. Okay, refer to the list of formula. So 3 point backward formula is number 8. Okay, number 8. So we copy first this formula. Okay. So the question asks, state the number of possible solutions could be obtained to approximate the first derivative of 2.0 by using 3 point backward formula. Okay, backward. So now if we refer to this data, so the h is 0.2 0.2, 0.2 and 0.2. But we also can find if we want to use backward, we can also use the step size h is 0.4. 0.4. Therefore, the answer for number 1 state the number of possible solution could be obtained to approximate the first derivative of 2.0 by using 3 point backward. So the answer is 2 because we have 2 step size. It's either 0.2 or 0.4. Okay, number 2. Calculate all the possible answer you state in 1. Okay. Question number 1, the answer is 2. Question number 2. Okay. Like I said just now, if let's say we consider h equal to 0.2. So we want to find f prime 2.0. Go to 1 over 2 2 plus f2 minus 0.4 to 1 over 0.4 1.8 plus f 1.6 equal to F2. So this is answer. This question is a bit different from the previous example because this one, the data given is in this form. Okay, that's why you need to consider the point here. But for this case, okay, for this case, you just get the value. If let's say f2, okay, just get this formula, f2, f 1.8, so 1.8, 1.6, okay, 1.6, okay. So 1 over 0.4, f2 is 5.3891 minus 4.4296 plus 3.780. So using your calculator, so you will get this answer. Okay, so this is the first answer. And what if we want to apply the step size h equal to 0.4, equal to 0.4. So f prime 2.0 equal to 1 over 2 h f(x) minus 4 f 2 minus h plus f 2 minus 0.8 1.0.8 6 plus f 1.2. Okay, so similar to this one, we can apply h equal to 0.4 because we can obtain this data from the table. Okay, 1.2, 1.6 and also 2.0. So equal to 1 over 0.8 5.3891 minus 46730 plus 2.6001. Okay. So using your calculator, so you will get this answer 5.0943. Okay. So the question number 2. So we can find two answers by using step size h equal to 0.2, and also another one we have find the answer by using the step size 0.4. And then number 3, the question number 3, given the actual value for f prime 2.0 is 5.3891, compare the result obtained in 2 and explain the error of the estimation in term of h. Okay. Question number 3. If let's say our h is equal to 0.2, so error equal to 5.30 for 8. So minus with 5.3891. So absolute value. So all should be in positive. So using calculator, so you will get this answer 0.0843, and h equal to 0.4. So the error will be 5.0943 minus 5.3891 absolute value. So using your calculator, so you will get 0.2948. So if we compare these two error, so h equal to 0.2 will give less error when compared to h equal to 0.4. So the conclusion that you can make, therefore the smaller value of h give less error. Okay, so this is the conclusion that you can make. Okay, so this is we have two exercise 3 and 4. I have given the answer. You need to try. Okay. Alright. Okay, that's all. Bye. All the best.